Have you ever gazed at the night sky and wondered, how did all this come into existence? As humans, we've been captivated by the night sky for millennia. Our ancestors looked up and saw a canvas of twinkling stars, and we've been trying to decipher this cosmic puzzle ever since. The universe, with its infinite vastness and awe-inspiring phenomena, has always been a subject of fascination. Its beginning, however, remains one of the greatest mysteries. Over the years, scientists and philosophers alike have proposed various theories to explain the inception of the universe. From the Big Bang theory, where the universe was born from an infinitely dense point, to the steady-state theory, suggesting an eternal, unchanging universe. Each theory presents a unique perspective, a different piece of the cosmic puzzle. Yet the question remains, how did this vast, complex universe come into existence? So let's embark on this cosmic journey and try to unravel the secrets of the universe. Imagine a hot, dense point smaller than a single atom. This, according to the most accepted theory, was the birthplace of our universe. In the beginning, there was nothing, only a singularity. A point so densely packed and unimaginably hot, it was smaller than a single atom. This was the stage for what we now call the Big Bang, a cosmic event that would trigger the creation of everything we know today. This theory suggests that around 13.8 billion years ago, this singularity started to expand, and it didn't just grow a little, it inflated at an unprecedented, almost inconceivable rate. Picture it as an explosion, but not an ordinary one. This was an explosion of space itself, a rapid stretching of the universe in every possible direction. But what caused this expansion? Well, we're still not entirely sure. Some believe it was due to quantum fluctuations, while others consider it a result of dark energy. The truth is, we're still piecing together the puzzle. As the universe expanded, it started to cool down. The intense heat and energy began to transform into particles. The first ones to form were quarks and leptons, some of the smallest particles in existence. These particles eventually clumped together to form protons and neutrons. And within the first 3 minutes of the universe's life, these protons and neutrons began combining to form hydrogen and helium nuclei. Over time, these atomic nuclei attracted electrons, creating the first atoms. These atoms were the building blocks for everything we see around us, from the distant galaxies to the screen you're watching this on. The Big Bang theory, while still a theory, is the most widely accepted explanation for the birth of our universe. It's supported by a range of evidence, from the cosmic microwave background radiation to the large-scale structure of the universe. And just like that, from a tiny, dense point, the universe as we know it began to form. But what if the universe has always existed in its current state? Let's dive into an alternative perspective, the steady-state theory. This proposition took root in the mid-20th century and was primarily championed by astrophysicists Hermann Bondi, Thomas Gold, and Fred Hoyle. The steady-state theory presents a view of the universe that is both constant and infinite. It challenges the Big Bang theory's concept of a singular starting point, and instead proposes that the universe has no beginning or end. This theory argues that the universe maintains a consistent density despite its expansion. Now you might be wondering, how is that possible? Well, it's all down to the concept of continuous creation. The steady-state theory suggests that as galaxies move apart, new matter is continuously created at an incredibly small rate, filling the gaps left behind. This process ensures the universe's density remains constant over time. To put it simply, imagine a loaf of raisin bread dough rising in the oven. As it expands, the raisins move further apart, similar to galaxies in our expanding universe. Now, imagine if you could continuously add dough in between the raisins as they move apart, maintaining the same density of raisins throughout the loaf. That's the essence of the steady-state theory. However, it's important to note that this theory has faced significant challenges. Observations of the universe have shown an evolution of galaxies, with more complex structures appearing over time, contradicting the unchanging universe proposed by the steady-state theory. Also, the discovery of the cosmic microwave background radiation, a relic of the Big Bang, has provided strong evidence against continuous creation of matter. Despite these challenges, the steady-state theory has played a crucial role in shaping our understanding of the universe. It forced scientists to test and refine their theories about the cosmos, leading to advancements in our knowledge. This theory, while less accepted, still holds a certain charm for those who like to consider an eternal, unchanging universe. But what if our universe is not the only one? Imagine for a moment the possibility that our universe, vast and infinite as it seems, is merely a small bubble in an infinite sea of other universes. This is the fascinating premise of the multiverse theory. The multiverse theory is a hypothesis in cosmology that suggests the existence of multiple universes, also known as parallel universes or alternate realities. The theory proposes that our universe is just one of an infinite number of universes, each with its own laws of physics, dimensions, and even time flows. In the grand scheme of things, our universe might be just a tiny speck in the cosmic ocean, one among an infinite number of other universes, each with its own unique properties and characteristics. This idea is not just a figment of science fiction, but a serious proposition entertained by many physicists and cosmologists today. The concept of the multiverse has its roots in the field of quantum mechanics, a branch of physics that deals with phenomena on the microscopic scale. Quantum mechanics is notorious for its strange and counterintuitive predictions, one of which is the idea of quantum superposition, the notion that a particle can exist in multiple states at once until it is observed. Quantum superposition led to the concept of the multiverse. The idea is that for every possible outcome of a quantum event, a new universe is created. In one universe, you might be listening to this video. In another, you might be the one creating it. The multiverse theory, while still speculative and unproven, opens up a whole new realm of possibilities. It challenges our understanding of reality and forces us to rethink our place in the cosmos. If the multiverse exists, then the cosmos is far more complex and fascinating than we could ever have imagined. The concept of multiverse pushes the boundaries of our imagination, doesn't it? It's a thought that stretches our comprehension to its limits. But isn't that what makes the study of the universe so endlessly captivating? Now, let's consider a theory that combines the Big Bang and the multiverse theories. The cosmic inflation theory, a fascinating concept that adds a twist to our understanding of the universe. Imagine, if you will, a universe that's not just expanding, but doing so at an incredible speed. This is the core idea of the cosmic inflation theory. It proposes that the universe, in its infancy, underwent a period of rapid, exponential expansion, much like a balloon being blown up. This sudden inflation occurred in less than a blink of an eye, in the minutest fraction of a second after the Big Bang. But what's even more intriguing is what happened next. After this rapid inflation, the universe didn't just stop expanding. Instead, it shifted gears, slowing down to a more gradual rate of expansion, a rate that continues to this day. This switch from rapid to slow expansion is like stepping off a high-speed elevator onto a leisurely moving sidewalk. Now here's where things get really interesting. This theory suggests that our universe might just be one bubble in a cosmic foam of countless universes. During the rapid inflation, bubbles of space could have formed. Each bubble then expanded at its own pace, potentially giving birth to other universes. These universes, including our own, could be part of a larger multiverse, each with its own laws of physics and unique cosmic history. This idea of a multiverse born out of the cosmic inflation theory is a tantalizing one. It opens up possibilities that are as endless as the universes it proposes. Could there be other versions of us out there, living in these other universes? The possibilities are mind-boggling. The cosmic inflation theory is not just a theory about the past. It's a theory about our present and our future. It could potentially explain the large-scale structure of our universe, providing a framework for understanding the cosmos on the grandest of scales. This theory could potentially explain the large-scale structure of our universe. We've journeyed through various theories about the beginning of the universe. We began with the Big Bang Theory, the widely accepted belief that the universe originated from a hot, dense point and has been expanding ever since. Then, we explored the steady-state theory, which posits that the universe has no beginning or end and maintains a constant density. We delved into the multiverse theory, a fascinating hypothesis suggesting that our universe is just one of an infinite number of universes existing side by side. Lastly, we investigated the cosmic inflation theory, which proposes that the universe underwent a rapid exponential expansion shortly after the Big Bang, setting the stage for the universe as we know it. While we may not have definitive answers yet, the quest to understand the origins of our universe continues to inspire and captivate us. So next time you gaze at the stars, remember, you're looking at a grand cosmic story waiting to be fully told.